you doing? I'm your man, John Wilson, baby. We got a good one for you today to do. Module 1, Lesson 1, Part B. We're going to finish up that first lesson. We're going to work with rational and irrational numbers. Our goals today. All of you will understand how to square and cube a number. Then you will take square and cubic roots. You will identify rational and irrational numbers. You will also estimate irrational numbers. If you have your trusty TI-30XA calculator, brought to you by the wonderful people at Texas Instruments, please take it out now. Okay, so we're going to start with square. You've probably seen this before, just in case you forgot. Squaring a number is done by multiplying a number by itself. You're going to multiply the number by itself. Now be careful. When I say by itself, I don't mean you're going to multiply a positive 4 and a negative 4. Yes, they're both 4, but they're very different. Positive 4 and negative 4 are not the same number. To be considered a true square, the numbers must not only be the same, they must have the same sign, positive or negative. So they're both positive 4s, they're both negative 4s, we're happy. Must be the exact same number. When squaring numbers, we use this little exponent, 2, to indicate the square. So you may see something like 1 raised to the second power. We can expand that out. It becomes 1 times 1, and everybody knows that 1 times 1 is? 1. And we repeat the process. 2 to the second power. What I do want you guys to be careful for is that this does not mean 2 times 2. This does not mean 3 times 2, or 4 times 2, or 5 times 2. It simply means we're raising that to the second power, so you're going to have 2 2s, 2 3s, 2 4s, 2 5s, 2 6s, 2 7s, 2 8s, 2 9s, 2 10s, so on and so forth. Then you're going to multiply them together. We're going to complete this square chart right now because this is super important for what we're going to be doing throughout the rest of this lesson. So 2 times 2 gives me 4. And you need to know all these, so I would take a little bit of time to memorize these later on because you need to know all of them. 3 times 3 is? 9. Now 3 plus 3, 3 times 3. 4 times 4 is?
16.
16. 5 times 5 is?
25.
25. I'll give you guys a second to catch up.
Okay.
And we keep on going right down through the line. We go to 6 times 6.
36.
What is it?
36.
It's 36, okay? And you go on to the next one. What's 7 times 7?
49.
49. So 6 times 6 is 36. 7 times 7 is 49. What about 8 squared? What are we multiplying there?
8 times 8 by itself.
8 times 8. They're both positive. 8 times 8 is? 64. 9 squared is the same as writing? 9 times 9, which equals? 81. As we get higher and higher, anything past 10, people start to drop off. Like, wait, what's 14 times 14? Let's see. 10 times 10 is? 100. You know that. 11 times 11?
121.
121. Good job. 121. You have to know all these up to 15 by heart. 12 by 12. 144. There you go. 13 times 13. Anybody? 169. Not a lot of people answering now. Like, wait, I got to get my trusty calculator out. But you need to know how to do these without the aid of a calculator. So you need to know how to multiply 14 by 14 by hand for parts of your exam and parts of your state test. It's also good to know your times tables up through 15 because you can be a lot quicker. Save yourself some time. 14 times 14, anybody?
196.
196. And then last but not least, 15 times 15 is 225. All right. So we've completed our square chart. Now this is a square chart. Later on, we'll be taking the square roots, which means that we'll simply be going backwards. Because when you square a number, and we'll get to this later, 2 times 2 is 4, I can also go in and take something known as the square root, which is going to tell me, okay, if I take the square root of 4, it's going to tell me what 2 numbers I have to multiply to get 4. We know that I have to multiply 2, so the square root of 4 is 2. We'll get to that later on. Anyway, right now I want you to understand that here, all my numbers were positive. But I can square anything. I can square positive numbers. I can also square negative numbers. So here, I'm going to square negative 3, which means that I'm not going to have negative 3 times 3. I'm going to have negative 3 times negative 3. This is where you have to remember the rules from last time. When you multiply 2 negatives, it makes a positive. So negative 3 times negative 3 makes?
9. Positive
9. You don't have to write the positive sign. You just have to know for sure that it's positive 9. Okay. I want to expand this out. So let's start involving the kids. Let's go to the card. Let's go to my main homie, Mr. Crockle. Crockle! -4 squared. When you expand that out, what are you going to write?
-4 times -4.
-4 times -4. Easiest way to write it? With parentheses. Makes it nice, makes it easy, makes it clean. You can use the little dot if you want to. What I don't want to see is -4, then the multiplication sign -4. We're in pre-algebra now. We try to do away with that, except for scientific notation. That's probably the only time you'll see it. -4 times -4, Mr. Crockle, is what?
16.
Positive.
Positive 16.
Positive 16. Good job. Always make sure you say to yourself it's positive or it's negative. That way, when you're taking a quiz, a test, classwork, homework, you send it to yourself, you write it down on a piece of paper. So we squared positives, we squared negatives, we can also square decimals and fractions. We can square everything, we can square anything we want. When I have a decimal, same process. You can either do it by hand, you can use your calculator, whatever you want. 0.05 squared is the same as writing 0.05 times 0.05. And that's going to give me 0.0025. It is. If you don't believe me, check it with your calculator. Type in 0.05 times 0.05, and you'll get 0.0025. You absolutely will. You can, if you want to. I'm showing you both ways, because I want you to understand that both of these mean multiplication. Sergio Pereira, I have -0.4 squared. So when I write that out, what am I going to write?
-0.4 and multiply
By -0.4, by the same thing. Good. So -0.4 times -0.4, write it any way you want. With a little dot, with parentheses. And when you multiply that all the way out, Sergio, what are you going to get? You got a calculator. Or you can try to do it in your head, whatever you want. I'm going to do this. What's up? I don't want the answer. He's working on the answer. You got a question? Oh, you got the answer? You should. What you don't have is a pencil. Why are you using a pencil? You can't erase that. Don't make a boo-boo. What do we got?
0.16.
Positive 0.16, or positive 0.16. Now, I'm writing it both ways. You notice here I didn't write the 0 before the decimal. Here I did. Does it really matter? Doesn't to me. You can write it with the 0, without the 0, I don't care, as long as the decimal's in the right spot and these numbers are in the right spot. Okay, so we squared positive numbers, negative numbers, positive and negative decimals, and now we're on fractions. People start seeing fractions, and they don't realize that fractions, whoa, I forgot about that. Let's go back here. They don't realize that fractions, they think fractions are scary. They think fractions, I don't like fractions. Well, you know what? The first letter in fractions is F. That's also the first letter in fun, because fractions, they're fun. Yes, I say most of the cheesy lines for the video.
Fractions are freaky.
Fractions are fun. They could be freaky too. They could be fantastic. Anyway, so here we have 4/5 squared. Let me ask you a question. You're looking at this, without this here, if you just look at this, you're like, I don't know what to do. But how many of you know how to multiply 4 times 4? Most of you. How many of you know how to multiply 5 times 5? Then you can multiply this. You just separate it. You multiply the top, you multiply the bottom. So you square the numerator. What's 4 squared?
16.
4 times 4, which gives me 16. What's 5 squared?
25.
Which gives me
25.
16 over 25. You multiply the top, you multiply straight across. You multiply the bottom, multiply straight across. It's easy. Don't let fractions scare you, man. Like I said, fractions are fun. Dante Jackson. We have 1/12 squared. Tell me, what are you multiplying?
1/12 times 1/12.
1/12 times 1/12. Okay. So 1/12 times 1/12. 1 times 1, 12 times 12. Dante, on the top, what's 1 times 1? What's the product?
1.
And on the bottom, what's 12 times 12? What's that product?
144.
144. So when we square 1/12, we end up with 1 over 144. We square positives. We square negatives, decimals, fractions. It's not difficult stuff. You simply follow the rules. You take your time. You remember that 2 negatives make a positive. 2 positives make a positive when we're multiplying. Because whenever we're squaring, we're multiplying. Questions on the first slide? No? Okay. So, we squared. We went forward. The opposite of that is taking the square root. What's another word for opposite? A word that we use in math
Difference.
for opposite. Starts with an I.
Oh, inverse.
Inverse. A square root is the inverse operation of squaring. A square root tells us, okay, we're going to give you a number, whatever that number is. What two numbers did you multiply to get that number? We want to find the root. We want to find out where this all started. In other words, it undoes a square. Now, the symbol we use for roots is known as a radical sign. It's this little sucker right here. Radical. That's what it's known as. Shh, shh, shh. Now, we know from the previous slide that 7 times 7 gave us 49. But what if I did not have any of that information? What if I just said, hey buddy, I want you to tell me what the square root of 49 is? Which means that I want you to tell me, okay, 49, I want the root. I want you to tell me what two numbers you multiplied together. Remember, it has to be the same number with the same sign to get 49. What would you tell me?
I'll say it's 7 times 7.
I would just, right now, just say 7. Is it 7? Yeah, we know that because if we go back and we look, yeah, we multiplied 7 times 7 to get 49. And if you want to see how to do this on your calculator, here's how you do it. Take your calculator. The number we're trying to find the root of is 49. So we type in 49. If you have it, that's great. If not, look on with a friend so you know what we're doing. And then this little symbol right here, next to division, right to the left of division, it's a little radical sign with an X. That's a square root sign. So hit that. What'd you get? 7.
Oh, yeah.
It's 7. So the square root is 7. Now this can be written one of two ways. If you just see a plain radical sign with nothing, that indicates a square root. If you see something like this with a little 2, that's also asking you for the square root. Alright, I want you to see both ways. Because sometimes you'll see this on a test or an exam or a state test, and I want you to know that this is saying square root. And they'll probably give you directions, but just in case, I want to make sure that you know that this and this, they're asking you for the exact same thing. Square root of 49 is 7, square root of 49 is 7. The little 2 means that what two numbers did you multiply to get 49? Okay? So, perfect square roots. You know when we multiplied, we did 1 times 1, we got 1. 2 times 2, we got 4. 3 times 3, we got 9. So 1, 4, 9. All those numbers, if we were to go 1 times 1, 2 times 2, 3 times 3, you don't need to write this, just look. 1, 4, 9. All these numbers, if we were to go and take the root, these are known as perfect squares. What is the square root of 1? 1. What's the square root of 4? 2. What's the square root of 9? 3. But later on, I'm going to ask you something like this. These are all perfect squares. Because you notice how when I take the root, it's a nice juicy whole number. It's beautiful. I love it. But what if I asked you what the square root of 3 is? What is the square root of 3?
It's half.
1.5.
It's not 1.5. Do in your calculator. Do 1.5 times 1.5. It's not 3, is it?
No.
Ah, you see? I'll show you later on how to find this. These are known as perfect squares. This is known as a non-perfect square. These are, and you'll see this, you'll hear me say this a million times, these are rational. This is what's known as irrational. Even though it sounds like E, it's actually IRR. We'll get to that. All of that. Anyway, so we're back here. Perfect square roots. Perfect square roots have integer roots. Integer means positive or negative whole number. And it's written without decimals or fractions. So, for it to be a perfect square root, when you take the root, it must be a whole number. If you take the number, like 3, and you take the square root, you get some long decimal, that is not a perfect root. That's a non-perfect root. That's known as an irrational number. We will get all into that in detail. Right now, just know that these are perfect roots. So we take the root of 36, and that's 6 because we know that 6 times 6 gives me 36. It's a big circle. So the square root of 36 is 6 because the two numbers we multiplied to get 36 were 6. So that's a whole number. You with me? I can also take the square roots of fractions. Once again, you're not taking the root of 49 over 81. You're separating it. You're going to take the root of just the numerator. Do we know the root of 49?
Yeah.
What is it? 7. Do we know the root of 81?
Yeah.
What is it? 9. And it simply becomes 7 over 9. You're not taking the root of the whole thing. And I'm going to go back and I'm going to erase that real quick, and I want you guys to pay attention again. Because every year, I run into this issue. People totally forget how to take the roots of fractions. If you see a fraction, and you're asked to take the root, split it apart. Take the root of the numerator, take the root of the denominator. Every year I go through this, I want to make sure we get it right this year. The root of just 49 is?
7.
The root of just 81 is?
9.
And it stays a fraction. Yes?
So isn't it just like simplifying a number?
What do you mean simplifying? Now you're not really simplifying, right? Because simplifying indicates that 49 and 81 would have a greatest common factor that we could then simplify. That's simplification. This is rooting. It's different. We're taking the roots. We want to find what we got, how we got to 49, and how we got to 81. We multiplied 7 twice, we multiplied 9 twice. The root of this fraction is 7 nines. Make sense? Okay. So far we've rooted, and I've told you that everything has one root. It's a lot. Total lot. Every number actually has 2 square roots. And I can prove this to you. Every number has a positive root, such as 6, such as 7 nines. But what you may not know is that every single number actually also has an equal negative root. Here's how I can prove that. Watch this. I told you earlier that 7 times 7 equals 49. And if you take the square root of 49, you get 7. But isn't there another way to get to 49? What's the other way to get to positive 49? Negative 7 times negative 7. What does that give me?
49.
It gives me positive 49. So in reality, if I take the square root of 49, it's not just equal to 7. It's not just positive 7, it's also negative 7. We write it with this little symbol right here. Positive over the negative. It's written just like that. We're going to write it on the other page in a second. So the square root of 49 is not just positive 7, it's negative 7. You have to know that every single number has 2 square roots. A positive root and a negative root. Because 2 negatives make a positive, 2 positives make a positive. So I've proven to you that every number has 2 roots. It does. Every single number has 2 roots. We go back to the slide and we see, okay, every number has 2 roots, a positive and a negative root. Because 7 times 7 is 49. Guess what? Negative 7 times negative 7 is also 49. So when you write this, make sure that you're writing positive or negative 7. If I ever ask you for a square root, not a cubic root, which we'll do later, but a square root. If I ask you for a square root, you're going to tell me, hey man, it's a positive and a negative of the exact same number. And we'll try that right here. I'm going to take the square root of 0.64. I'm not, but Keenan. Where's Keenan? You got your calculator? You're going to take the square root of 0.64. So in your calculator, here's what you're doing. You're going to type in 0, the decimal, and then 64. And everyone do this with them if you got a calculator, make sure we know how to do this. And then you're going to hit the square root button. And tell me what you get.
0.8.
You get 0.8, but it's not just positive 0.8, it's also negative. Now your calculator won't tell you that. It's up to you to remember that every single number has a positive and negative root. How do I know that? Because if I multiply positive 0.8 times positive 0.9, I get 0.64. If I multiply 2 negatives, I also get 0.64. So make sure you include this little symbol right there. And that will give you a smiley face. You have to include that. All right, so those are perfect square roots. Yes, question?
For the positive and the negative sign, does that go in front of every answer?
It goes in front of every single square root. Yes, every single perfect square root. Every single one, okay? So if you have a perfect square root, if you put the number into your calculator and it gives you a number, not a long ending decimal, but it gives you a number, it gives you a perfect root like this, yes, you put a positive or negative, okay? I would just do it for all square roots. All square roots, positive or negative. Cubic roots, no. Every cubic number, every cubic root is just one root. Because, think about it this way. I don't want to jump ahead too much, but we said if we multiply 2 negatives, we get positive, right? Okay. But if I multiply 3 negatives, do I get a positive?
No.
No, I get a
Negative.
negative. That's why, as you'll see later on, every number may have 2 square roots, but only 1 cubic root. We don't need you anymore. All right. So those are perfect squares. We also have non-perfect squares. Remember that example from earlier, the square root of 3? If you put that in your calculator, you got a decimal. And your calculator, it ended. But in reality, if you take the root of any non-perfect square, such as 3, 40, 50, those decimals never end. And we show that by writing the first 3 digits. So in your calculator, everyone take the square root of 3. you get what, 1.732, and there's some numbers after it?
0.0.
So these are known as non-perfect squares. They are irrational numbers. That's IRR, AT, everyone should be writing this in, irrational numbers, IRR, ATIONAL, irrational numbers. If it's not a perfect square, then it's a non-perfect square. And every single non-perfect square, every single one, is irrational. They don't actually stop. Your calculator stops because your calculator can't go on forever and ever. But what we do to write that out is we write the first 3 digits after the decimal, and then you write 3 dots after it. You have to do that. That shows anybody who knows anything about math that that is an irrational number, and this actually continues on forever. Square root of 40. Let's go to Annabelle Aiken. Hey, square root of 40. What'd you get?
Do I use my calculator?
Yes, you do. I haven't shown you yet how to do it without.
6, 3, 2, 4, 5, 5, and so on.
So you got 6 point something? There's a decimal. 6 point.
6.324 dot.
Okay, so 6.324 dot. That's how you write it. The 6, the decimal, the first 3 digits after the decimal, the dot. That tells me that this non-perfect square, that this decimal does not terminate, does not repeat, it goes on forever into the wild blue yonder. Yes?
So you make sure you add the 3 dots too.
Add the 3 dots, because if you don't add the 3 dots, there's a big difference between this, and this. That's, what is that? What type of decimal?
Terminating.
That is? And this goes on and on and on forever without terminating or repeating. These are both rational. We'll talk about number types in the next lesson. But this would be irrational. You have to know the distinction between the two, which we really get into more next time. Camila Pinto, where are you at?
Here.
Oh, sorry, hold on. You had a question?
Can you start your calculator?
How do you square? Okay, on let me show you this one. Okay, so what you would do is you would hit the number and then that little X2. Hit this one. Okay, you need this one. All right. Yes. What happened? I have. Yeah, I absolutely have. A couple people already got them. That's why I'm calling on the cards. All right, Miss Pinto, where you at? You're right there. Miss Pinto, what's the square root of 50? How would we write it?
0.071.
0? Try this.
7.071.
7.071 dot. If you don't write the dot, you're telling me that decimal stops. And that would be wrong, so be careful. First 3 digits, then the 3 dots. Thank you very much. All right, so that was square and square roots. Any questions on how that works? No? Now, very important, like I said, this chart right here is key, probably to the whole module. You need to know these perfect squares. So at some point, go back and try to memorize them the best you can. You need to know 1 through 15. The first couple are easy, but I think 11, 12, 13, 14, 15, we could all use some help on, all right? So, 4, 3, 2, 1 on this. So that was square roots. Now we're going to talk about cubing a number and cubic roots. When we square a number, we multiply it by itself. When we cube a number, we multiply it by itself and then by itself again. So, 4 squared is 4 times 4. But 4 cubed is 4 times 4 times 4. Or negative 4 times negative 4 times negative 4. It's 3 in a row. So, cubing a number is done by multiplying, like I said, by a total of 3 times. And once again, to be considered a cube must be the same number with the same sign. So 3 times 3 times 3, or negative 3 times negative 3 times negative 3. It cannot be 3 times negative 3 times 3. That's not a true cube. All right, yes, what's up?
When you cube it, does it go like 3 times 3, 9, then times 3 again?
However you want to do it. If you want to, whatever way works best for you, right? So if we're cubing, let's say we have 3 cubed. You can do 3 times 3 times 3. You can do it like this. 3 times 3 is 9, times 3 is 27. If you want, you can break it up. Okay, 3 times 3, I know that's 9. You can bring this down, times 3, I know that's 27. It's whatever you want to do. If you can do it in your head, that's great. If you want to write it down like that, whatever way works for you, as long as you're getting 27. Back it up now. All right, so we're going to do the same thing. Positive integer cubes, negative cubes, decimal, fraction. Same thing. Show you all the different tricks, all the tricks. So like I did 3 cubed, We said 3 times 3 times 3. What does that give me?
27.
27. Once again, this is not 3 times 3. That would be 9. We're doing 3 times 3 times 3. You're not doing 6 times 3. You're not doing 10 times 3. How would this be written, Asanza? How would this be written?
6 times 6 times 6.
6 times 6 times 6. This is where a calculator comes into play. Do you know what 6 times 6 times 6 is, Mrs. Anza?
Oh, 216.
216. So 6 cubed is equal to 216. Mr. Tucker, 10 cubed.
Yeah.
How do I write that out? Long
10
form.
times 3 times 10 times
10 times 10 times 10. And then just Mr. Tucker, only Mr. Tucker, no one else. What is 10 times 10 times 10?
10,000.
Well, let's try this. Let's do 10 times 10. Just 10. What's 10 times 10? What's 100 times 10?
1,000.
1,000. Good job. So positive cubes are pretty easy. Once again, instead of twice, you're just multiplying 3 times in a row. We can also have negative cubes. Very important. If the number is negative, the cube will always be negative. Here's why. When you multiply out negative 2 cubed, we know that 2 negatives make a, but then a positive times that last negative will make our answer negative. So this will be negative. Every negative cube, the product will always be negative. Then you just do 2 times 2 times 2, which is, class, 8. Question?
So you know how when you said the one that has the bigger
That's for addition or subtraction. Yeah, this is multiplication. Here it's just same sign positive, different sign negative. So when we multiply these two, we get a positive, but we still, now that we're done with these, we still have a negative left. So a positive and a negative will make my product negative. So every negative cube, by negative cube I mean if the integer, the base, is negative, raised to the exponent of 3, when we cube it out, we're going to get positive, negative, therefore negative 8. We're good? Alright, let's go to Mr. Vidal. Negative 4 cubed, dude. I'm going to write that out. What's it going to look like?
Negative 4 times negative 4 times negative 4.
Bam! There it is right there. And then you multiply that out. Tell me, what's my product going to be? Just him, only him.
80.
Let's try it. Let's go through it step by step. Ignore the signs. We know it's going to be negative, right? Because every negative cube is negative. So we know it's going to be negative. You got me? Okay. One step at a time, dude. What's 4 times 4?
16.
16. Okay, good. Hold that number in your head. Now, can you do in your head 16 times 4?
Yeah.
What is it?
64.
Boom! There we go. Negative 64. And that is the cube of negative 4. Okay, so we've cubed positives. We've cubed negatives. We can also cube, by the way they're missing right here, write them in for me. We can also cube 0.7 and negative 0.8. Sometimes I will intentionally exclude stuff like this to see who points it out before me. That means we're cubing them. They weren't there. I want to see if anyone would point it out before I got to it. Sometimes I'll do that. Sometimes I will intentionally put an error up here, like I'll do 1/2, 1/2, 1/3, to see if anybody catches it before I get there. So look for it. I'll give you a ticket if you find a little mistake before I get to it, to see if you're paying attention. Or I'll make a mistake intentionally. I will multiply this out and I will say, okay, well this obviously is going to be 0.49. Of course that wouldn't work because the answer disappeared. But if you see me make a mistake like that, call me on it and say, hey, did you make a mistake right there? I'm like, you caught it. You caught it. And that's another way I can tell if you guys are paying attention. Alright, so we're cubing decimals. 0.7 times 0.7 times 0.7. Maria, what is it? 0.343. You can do it by hand, you can do it with a calculator, whatever works best for you. Hannah, Elbar, negative 0.8 cubed. Before we even start, we know it's a negative cube, so my product has got to be negative. Okay, and then Hannah is going to answer. We write that out. Negative 0.8, negative 0.8, negative 0.8. Just Hannah, what do you got?
Negative 0.5.
she got it, man. She got it. That wakes you up, huh? She got it. Yes, she did. Good job. All right. So we cubed positives. We cubed negatives. We cubed decimals. Now we're going back to our old friends, the fun fractions. When we cube a fraction, you do it just like we square a fraction. You don't worry about all this craziness. You just multiply 1/2 times 1/2 times 1/2, and you multiply straight across. So 1 times 1 times 1 is what?
3. And then
20.
And 2 times 2 times 2 is what? 8. Which means when you cube 1/2, you end up with 1/8. Sounds easy enough. Oh, I just called Marie actually. And the ostrich. And the ostrich. We have 3/5 cubed. How do you write that out?
3/5 times 3/5 times 3/5.
Bam. And then, how do you multiply that?
Multiply the numerator.
Multiply all the numerators and multiply all the denominators. So what's 3 times 3 times 3, dude? 27. Okay, and then what is 5 times 5 times 5? Solve a simpler problem. What's 5 times 5?
125.
125. He's got it. All right. So when we cube this sucker out, boom! 27 over 125. Don't take the whole fraction on all at once. Separate it. Cube the numerator, cube the denominator. So that's cubing, just like squaring. But just like squaring had an inverse, which was taking the square root, cubing has an inverse. It's known as taking the cubic root. All right, so we want to take a cubic root now. So the inverse or opposite of cubing a number is taking the cubic root. You're going to be given a number, and then you have to find what 3 numbers you multiplied in order to get that product. Okay, so unlike square roots, cubic roots only have one root. Not 2 roots, not a positive and negative, just one root. Either a positive root or a negative root. So we have positive roots, we have negative cubic roots. On your calculator, here's what you do. To take a cubic root, you are going to go and you're going to type in the numbers, such as 8. This is why we have calculators. 8, and then you're going to hit, where is it? Right here, second. It's that green button in the corner. So you're going to hit 8. You hit second. Then you're going to hit, see this button that says YX? Hit that. And then it's a cubic root. What number is that?
3.
3. So for cubic roots, we always hit 3. Hit 3. What do you get? And hit equal. 2. So the cubic root of 8 is 2. How do I know that? Because 2 times 2 times 2 gives me 8. So in case you want to write that down, here's the sequence. You are going to type the number. I'll use the hashtag sign. You're going to type the number. Then you're going to hit second. And then you're going to hit YX. And then for cubic roots, we always type in the number
3.
3. That's how you take a cubic root on a calculator. The number, second, YX, 3. And remember, I'm only teaching you the TI-30XA. That's why I was very insistent. Robin? Oh, I'm sorry. Good job, Colton. You must hit that equal sign. So whatever your number is, then second, then YX, then 3, then hit equals. I would suggest you write that down on your paper so when you go home later, you know how to find these. You need to practice. You will absolutely be able to use a calculator for any cubic roots. But if you don't have a TI-30XA and you don't know how to do this, I'm sorry. I'm only going to show you the method for a TI-30XA because that's the ones that we use in here. Brought to you, once again, by the wonderful people at Texas Instruments. Keep on doing what you're doing. TI-30XA. All right, back to this. So, cubic root of 27. That being said, let's see who wrote it down. Manuel Rodriguez. We want the cubic root of 27. What do you got?
I got 3 because 3 times 3 times 3 equals 27.
3. Good. Because 3 times 3 times 3, like you said, equals 27. So if we back that out with the cubic root, he's right. We end up right at 3. Once again, the number, second, YX, 3 equals something.
I'm taking
You're taking it? I'm going to bring you a ticket.
14.
I'm going to bring you a ticket.
it.
There you go. You reminded me. That's okay. You have one of those? Yeah, what are you? What's up? Okay, so positive cube roots. Negative cube roots. Negative. Once again, pay attention. You have to turn the number negative or you'll get the wrong answer. So we're going to go back here. This is for positive. For negative, everything's the same except for this. When you type in the number, after the number, this little button right here next to the equal sign, the one that looks like this, it's positive, the little arrow, negative, the little arrow. You're going to hit the number, then that, and then you'll hit second, yx, 3 equals. That's the only difference. This is for positive, that's for negative. So negative, change it, put the number, change it, make sure you change it to negative, or it'll give you the wrong root. Run through those buttons in the calculator, it'll spit out the correct root. I'll let you write it down. That's the only change. Once again, if you don't have the TI-30XA, I'm sorry. Try to pick it up. You can always go back, watch the video in case you forgot something or missed something. All the tutorials right there.
Got it.
All right. Can I change it back?
Maybe.
Okay. So we want to take the cubic root of negative 64. What'd you get?
I got -4.
Negative 4. Perfect. Negative 4. And that makes sense because I said every negative number will have a negative root. If we have a negative cube, it's negative. Therefore, its root also has to be negative. Okay, so I'll give you a ticket on that one. And then let's go to Mr. Meza. Where's Meza? That's you. Mr. Meza, cubic root of negative 125. What you got, man? Negative 5. You got it. Good job. So once again, you're going to put in your calculator, in case you don't know how to do this, it's just 5, make it negative, second yx 3 equal sign, oh sorry, 125 negative second yx 3 equal sign, and you get negative 5. I want everybody to try that. Make sure you get negative 5 out the other side.
125.
125 is the number. Now 125, make it negative with that little button right there. Then hit second yx 3 equal sign. Everybody should get negative 5. If you don't, let me know. Okay. So here's what we do. You gotta put in 125. So put in 125, negative, second, yx 3 equals. Usually 5. That's what I did the first time. Okay. It's 1225.
Oh, we still putting the second?
Yeah.
Don't ask that. Oh, thank you. Okay, so we're through the negative cubes. Now, decimal cubic roots. I'm just going to go around and call some people. Everyone should know how to take a cubic root right now. Let's see. Let's go to, I already called him. Got mixed up. Brian Stockwell, where you at? Brian, cubic root of 0.8. What you got? We'll let you cycle through some problems. Everyone should be trying to see if you get the right answer. Yeah. 0.8.
.928 ...
Anybody have a different answer?
I got 928.317.
0.8
No, I got
second yx3. Hold on. 0.8 second yx3 equals 0.928.
Yep.
Okay.
I got that.
Point.
Wait, 0.9.
Point 928. And then what are you supposed to have after that? Dot, dot, dot. Okay. What about the next one? Who was that? I owe Brian a ticket for that. What about negative 0.216? Let's see. What'd you get for that? Let's go to Jason Francois. He left. Okay. Jiwa.
Yes.
What'd you get?
Negative 0.6.
Boom! There it is, right there. Good job. Okay, so cubic roots of positive numbers, negative numbers, cubic roots of decimals. Now we're going to take cubic roots of fractions. Do you do the whole thing at once? No, you split it apart. Somebody tell me, we've done it a couple times. What's the cubic root of 8? 2. What is the cubic root of 125? 5, which means that if I take the cubic root of 8 over 125, I should get 2 over 5. And then let's go to Mr. Tucker. Back to you, you came up again. Mr. Tucker, the last one right there. Cubic root of 27 over 343. What you got? Right there. Yeah. No, the cubic root. Take the cubic root of 27. Clear it out. Do 1/2 at a time. And remember, you're going to split these apart, guys. So you're going to take the cubic root of 27 and the cubic root of 343. Stockwell, did I give you a ticket? I did? Okay. And G, what? Did I give you one?
Yes.
I did? Okay. Okay, so the cubic root of 27 is 3. What's the cubic root of 343? Just him, just him. Let's see if he's correct. Boom! There it is. All right. 3 7s. Remember, you separate. Take the cubic root of the numerator, cubic root of the denominator. Boom. Shakalaka. There you go. Questions on this one? Any questions? Section 2 has been completed. 4, 3, 2, 1 on this. So, one last thing. Now for this, all the calculators, you can put them down. We're going to use them to check. You don't have to put them away. But we're doing this without calculators. Because you need to know, no, leave them out. You can use it to check. You don't have to put them away. But we're doing this without. You need to know how to do it with and without a calculator. We are going to be estimating. Now, let me ask you a question. Estimate. If I estimate something, is that an exact true answer?
No.
No, it's an estimate. It's going to be close. It's going to be in the ballpark. But it's not going to be exact. You have to know how to estimate irrational roots. The goal of this is to really see if you can use those mathematical brains that I know you all have to try to take something like this. Is that a perfect square?
No.
No, it's not. To try to take a non-perfect square and then estimate. I like to use the word guesstimate because you're kind of guessing. Guesstimate as close as possible as you can to the actual decimal. So non-perfect squares, like I said before, are irrational numbers. Now, if it's a perfect square, well, it's really easy for me to take the root. I know what it is. Square root of 36 is 6. Square root of 49 is 7. Square root of 100 is 10. But if I'm trying to find the square root of 40 without a calculator, I'm going to have to estimate it. And the way to do that is to realize that we're going to go all the way back to the beginning of our lesson. We made that perfect square chart. And then I said, well, if you can do 1 times 1, that gives you 1. And the root of 1 is 1. 2 times 2 gives you 4, and the root of 4 is 2. 3 times 3 is 9, the root of 9 is 3. We can use our perfect square roots to help us kind of narrow down where the square root of 40 is. So we look at 40, the square root of it, the square root of 40, and we try to identify kind of where this falls in relation to all of our perfect squares. So we go through our list of perfect square roots, and we see that 40 falls in between which two numbers? 36 and 49. Are those both perfect roots? Yes, they are. 36 roots to 6, 49 roots to 7. So we know that the square root of 40 is going to be somewhere between 6 and 7. Now, that would be a decent estimate. We want to get a little closer. So we know that it's going to be somewhere between 6 and 7. The way you get closer is this. How many of you can subtract simple 2-digit or 3-digit numbers, or 1-digit numbers? Most of you. So here's how we're going to get very close to the actual decimal equivalent of the square root of 40. We need to find the difference. We know, like I said, it's between 6 and 7. So is this going to be larger than 7?
No.
Is it going to be less than 6? No. We know that it's going to start with 6. It's going to be 6 point something. But we want to make a fraction, which we can go back and turn into a decimal. So we do this. We say, okay, we find the distance between 36 and 40. The way to do that is what's 40 minus 36? 4. Hello. It's 4. So the distance is 4. You find the distance between the smaller perfect root and the number, and then you find the distance between the smaller perfect root and the larger perfect root. What's the distance between 49 and 36? What's the difference? Anybody? 13. And that right there just gave me my answer. I have the fraction, which is going to be about as close as I can estimate to the square root of 40. So we know that my fraction, my mixed number, is going to start with what number? 6. And then my fraction is going to be 4 over 13. That's my estimate. It's just that simple. Nothing else you got to do. And if you check your calculator, if you take the square root of 40, and then you find what 6 and 4/13 is as a decimal, you'll find out it's really close. In fact, we'll do this on a calculator now. What's the square root of 40? 6.324. So it's actually 6.324 ... Now, if we turn this into a decimal, you do that by doing this. You do 4 divided by what? 13. And you can't forget the 6, so plus 6, and that gives me what? 6.307. So did I get close? I got really close.
Very close.
Very close. I got almost to the nearest 100. It's just that simple. You find out whatever 2 roots it falls between, and then, okay, I'm trying to find the root of 40. So the distance here is 4, and the distance here is 13. It's just that simple. 6 and 4/13. We're going to do 2 more, so you can wrap your heads around this. Some of you are like, well, this is kind of a new concept. What are we doing there? Can we see some more? Sure. Okay, let's try 2 more. Eyes up here. Door, please. Okay, so we want to find the square root of 75. The first thing we have to do is we have to go to our chart, and we have to realize that 75 falls in between what 2 perfect squares, class? What 2 perfect squares? 64 and 81. So what's the square root of 64? 8. What's the square root of 81? 9. Okay, sum it. So we find the distance. I just called him. Azanza, what is the difference between 64 and 75?
75?
Yeah, 64 and 75. What's the distance there? Or the difference? 75 minus 64 is? 11. So my numerator is going to be 11. Now I just need the denominator. Ms. Zamas, what is my denominator going to be for that fraction I'm going to create?
Well, the distance between 64 and 81.
Is just her, please. It's okay, let her work it out. You got it already, just wait. Everybody.
17.
17. So my numerator will be 11, my denominator 17, and that means my estimate is going to be 8 and 11/17. Or as a decimal, that becomes 8.647. Write that in, then I want you to take a second on your calculator, and I want you to find the root of 75, and I want you to tell me how close we got. What's the root of 75 on your calculator?
4.2.
No, 75. Square root of 75. 8.66. So did we get close? We got really close. Remember, this is an estimate. We're trying to get as close as possible. So this is 8.647. The actual root of 75 is 8.66. It is close enough. It's just an estimate. We got 1 more to do. Julio Dominguez. Julito, walk me through this, man. We want to find the square root of 3. What roots does that fall between? What perfect squares? They're right up there, man. 3, go to your chart. 3 falls in between 1 and, and 4. So the square root of 1 is 1, the square root of 4 is 2. So we know that this is going to fall in somewhere between 1 and 2. So I know that it's going to be 1 something, 1 point something, for sure. Now, to find my fraction, what's the distance between 1 and 3? 2. What's the distance between 1 and 4? 3. The fraction becomes 1 and 2/3, which as a decimal is 1.6 repeating. Now, as the numbers get smaller, the estimates actually get a little farther up. If you take the actual square root of 3, you get 1.73. So that wasn't as close. It was about 7/100ths away, but it's still close enough. As the numbers get bigger, you get even closer and closer and closer. But it's an estimate. It doesn't have to be exact, but you have to know how to do it this way. Does anybody have any questions on this? Yes, what's up?
What's the equation to check yourself with?
How do you check this? You simply take the number, like 75, and you take the square root. And you see how close you got. So it's 8.66, whereas that's 8.64, so it was close enough. Okay? Any questions before we wrap it up? Yes? Sure. Okay. So let's do this. Here's what I want you to do. I want Miss Aiken, since you weren't in here, give me a number, any number, between 1 and 100. 73. Okay, so here's what we do. We want to estimate the square root of 73. You with me?
Yep.
Okay. So, to do that, we have to find the perfect square beneath it, the perfect square above it. Anybody want to tell me what the perfect square beneath it is?
8.
8, which is 64, which is equal to 8. So we know that this number is going to be between 8 and what's above it? 9, which is 81. So we know that this number is going to fall somewhere in between these two. The way we find the fraction is we do this. We say, okay, I need a numerator and a denominator. For my numerator, I do 73 minus 64. What is that? 9. For my denominator, I do 81 minus 64. What is that? 17. And you're done.
Wait, why did you draw an arrow with an 8?
Because I was showing you that this number is going to start with 8. It's somewhere between 8 and 9, right? Because on the left side, we're at 8. On the high side, we're at 9. So square root of 73 falls somewhere between 8 and 9. How can you prove that? Check it on your calculator. What's the square root of 73? Do you have a calculator? 8.54. So it's 8.54 something something. 8.54 4 dot dot dot. And then if you were to actually turn this into a fraction, into a decimal, it becomes 8.529. So does this method get us really close? Yes, it does. Do you want to see one more?
Yeah.
You see one more? One more. Who says yes?
Yeah!
People say yes. If anyone, one person says yes, we do more. We don't move on until everybody has a good idea. So let's do another one. And I would pick numbers higher than 100. I don't care. If you want to do that, we can. So if you want to pick a number between 1 and whatever, like 1 and, let's just keep it reasonable here. 1 and 250. Let's go to, Vidal, give me a number between 1 and 250.
67.
Well, we've done a lot of things between 8 and 9. Let's go a little higher there. Give me something in the hundreds.
110.
110. Okay. So we want to estimate the root of 110. So we need to find the perfect square beneath it, the perfect square above it. Can anybody tell me what the perfect square beneath this is? It's 10. What's 10 times 10? 100. So square root of 100 is below it. So we know that this number is going to fall in between 10 and 11. You start to see how this works? So it's somewhere in between these two numbers. Now, we know it's going to be 10 and a fraction. So we need our fractions. We get our numerator. What's 110 minus 100?
10.
10. What is 121 minus 100?
21.
And there's your answer. That's your estimate. Make sense?
Yeah.
Anybody still want another one? One more?
Yes.
Can you show how to turn it into a decimal one more time?
To turn this into a decimal on your fraction, here's what you do. On your calculator, here's what you do. Take the numerator, 10, divide it by the denominator, which is 21. That equals, and then add the 10.
So 10.
Plus 10, and you get 10.476. So 10.476, let's see how close our estimate was. Let's do the square root of 110. 110 root is 10.488. So we're really close. We were only 8 1,000ths away. That's pretty close. It's an estimate. It's not supposed to be exact. What's up?
So like you subtract.
I subtract 110 from 100 to get my numerator. I subtract 121 from 100 to get my denominator. One more, real quick. I know. One more, real quick. Square root of 33. What's the perfect square below it? 5. So 25. Square root of 25 is
5.
5. And 36. Square root of that is 6. So this is going to be somewhere between 5 and 6. So we need our fraction. It's going to be 5 and a fraction. 33 minus 25 is 8. 36 minus 25 is 36 minus 25 is 11. And that's your answer. Did we get it?
Yes.
We good?
Just
Sure.
Thank you.
Because we're trying to find the distance. This is the base number. That forms our fraction. If you did 36 from 33, you'd be basing it on the irrational number, which we don't know. Okay. But no, I like the way this class works. I want you to understand that if there's one person in here who doesn't get it, we'll do it again and again and again. I will not move on. I want everybody to get it because I don't think it's fair if you're just sitting there like, I don't get it. Oh, well, you know what? Do your homework. Talk to you later. If we have time, we'll do as many as it takes. for us to get the answer right. So I think everyone's got a pretty good idea of what we're doing here now. So,
Yes.
yes?
Yes.
If no, we can do another one. It's totally fine with me.
Can we
Okay.
do one more? Let's do it.
Okay.
Yeah. Come on.
4, 3, 2, 1. How about you do one? We'll see what you got. 4, 3, 2, 1.